Hello guys, this is Camille Gamarcha, the in charge of discussion in this group.
Hello guys, I am Janelle Rosette G. Pineda, the in charge of the procedure in this group.
Hello guys, this is James Gertayan, in charge of the table on this video.
I'm Rose Castellano, in charge with the analysis of this group.
I am Dr. Paul Mayari, the in charge of the conclusion in our group.
Hi, this is Brian Chadia Palma, and I am in charge in parallel.
Hi, I am Justin J. Peron, and I'm in charge of the editing of this group.
The color coding uses colored bands to quickly identify a resistor's resistive value and its percentage of tolerance with the physical size of the resistor, indicating its wattage rating. The colors orange, white, yellow, and gray are used as tolerance code on 4 bands resistor only. The 4 bands resistor have tolerance of 5%, 10%, and 20%. The color code used to denote the tolerance rating: orange 5%, white 10%, yellow and gray are 20%.
In this laboratory experiment 3, we determined the value of resistance of a fixed resistor using the color code technique. First thing we have done is we searched images of the 5 resistors containing 4 color bands. Secondly, we determined the colors of the bands in different resistors and input the results in the table provided. Next thing we have done is find the value of the fixed resistor, but for that we have made certain computations. For the computations, the values of the different color bands were taken from the chart provided. The first and second values of the color band serves as the whole number, the value of the third color band as the multiplier, and the value of the fourth color band as its tolerance. We then multiply the whole number into the multiplier given and find its percentage afterwards. After getting the value needed, we then added and subtracted it in the product of the whole number and the multiplier. We repeated the process all throughout the 5 different resistors and input all the acquired data in the table.
The result of the first resistor is ranged to 370,500 to 409,500 ohms, and the second resistor is ranged to 950,000 to 1,050,000 ohms. In the third resistor, 2,565 to 2,835 range of ohms, while in the fourth resistor is ranged to 2,160,000 to 2,640,000 ohms. And the fifth resistor, the range is 4,465 to 4,935 ohms.
In a 4-band resistor, the first and the second color will serve as the whole number. The value of the third color is to be multiplied to the combined values of the first and second colors, which is why it is called the multiplier, and the value of the fourth color is the tolerance. Let us take, for example, the first resistor. The first color band is orange, while the second color band is white. The value of orange in the resistor chart is 3, while the value of white in the resistor chart is 9. So combining the two, we have 39. The color in the third band is yellow, which is equal to the value of 10,000. So 39 multiplied by 10,000 will give us 390,000. The color in the fourth band is gray, which has a value of plus minus 0.05 tolerance. So 390,000 multiplied by 0.05 will give us 19,500. 390,000 minus 19,500 will give us 370,500, while 390,000 plus 19,500 will give us 409,500. So the range of the values will be from 370,500 to 409,500. In the second resistor, the color in the first band is brown, while the color in the second band is black. Brown has a value of 1 in the resistor chart, while black has a value of 0 in the resistor chart. So combining the two, we have done. The value of the multiplier is 100,000 given that the color is green. So 10 times 100,000 is equal to 1 million. The value of the tolerance is plus minus 5% because the color is gold. So 1 million times 5% will give us 50,000. So 1 million minus 50,000 will give us 950,000, while 1 million plus 50,000 will give us 1,050,000, which is why the range of values will be from 950,000 to 1,050,000. The same is the process that we did in computing for resistors 1 and 2. We also did the same for resistors 3, 4, and 5. So in the third resistor, we have a range of values of 2,565 to 2,835. In the fourth resistor, we have a range of values from 2,160,000 to 2,640,000. While in the fifth resistor, we have a value of 4,465 to 4,935. Resistor is a resistor having a fixed, defined electrical resistance which is not adjustable. In an ideal world, a perfect resistor would have a constant ohmic resistance under all circumstances. This resistance would be independent of, for example, frequency, voltage, or temperature. Fixed resistors are by far the most widely used type of resistor. They are used in electronic circuits to set the right conditions in a circuit. Their values are determined during the design phase of the circuit, and they should never need to be changed to adjust the circuit. Resistor color coding uses colored bands to quickly identify a resistor's resistive value and its percentage of tolerance with the physical size of the resistor. The tolerance of a resistor is the maximum difference between its actual value and the required value and is generally expressed as a plus or minus percentage value. In a 4-band resistor, the first and the second color will serve as the whole number. The value of the third color is to be multiplied to the combined values of the first and second colors, which is why it is called the multiplier, and the value of the fourth color is the tolerance.
The colors adorning most fixed resistors serve a purpose beyond catching your eye. Color coding identifies the nominal value and tolerance of most resistors and have their values stamped on them. The color code starts near the edge of one side of the resistor and consists of several stripes or bands of color. Each color represents a number, and the position of the band indicates how you use that number. We get the nominal value of the resistance in ohms by putting the first two digits together and applying the multiplier. In this activity, standard precision resistors 4-color band was used. The first three bands indicates the nominal value of the resistor, and the fourth indicates the tolerance. Shown on the table above, resistor number 4 has the highest resistance in ohms, while resistor number 3 has the lowest resistance.
The objective of this laboratory experiment was to calculate the resistance value of a fixed resistor using the color coding technique. The experiment's findings indicate that the goals were reached. Based on the evidence provided in this experiment, we hypothesize that when only the positive tolerance is considered, all bands have a positive influence on the resistance rating. The fixed resistor value are determined by the color of each band and its equal value. In a fourth band resistor, the third band has a major effect on the resistor's resistance rating. The first, second, and the fourth band would then follow.